if I sound like I'm talking to people who aren't here. That's what I'm up to. So we'll go over the questions you guys have. So 10, 14, 17, and 18. Okay, so go through the questions you guys had. I think these are actually the same exact questions I had in my first hour class as well, so apparently.
That's easy.
So in our 30, 60, 90 triangle, remembering that everything is kind of based off the short side in our 30, 60, 90 triangle. In number 10, what side have they given us? They've given us the hypotenuse. So this is the hypotenuse. Where's the short side? It's actually y in this case. So in order to go back to the short side, so if I'm at the short side, or at the hypotenuse, to go back to the short side, I have to do what with it? Divide it by 2. So this is divide by 2. So I'm dividing 12 square roots of 3 by 2. And I know if that just threw you off, all you're doing is cutting the 12 in half. So it's 6 square roots of 3 is our y value there. Because you're just dividing basically what you can by 2, so you can just simplify that part of it. Now that I know that, that's our short side. Now to find our x, and I don't know if that's what threw you off, is typically on the notes I think we have called x the short side. They can call whatever they want to be the short side. You take the short side and you multiply it by the square root of 3. So 6 square roots of 3 times the square root of 3. Square root of 9, which is just 3. So that's just going to be 18 for that x. All right, we'll go to 14 then. I believe 14 is a 45, 45, 90. And I think this one I might have lied to last week. Someone might have asked me in here, will they do other square roots other than like square root of 2 or square root of 3? And I think I said no. And so this would have been a lie. So sorry if that was you who asked that, or if you heard me say that. This is M and N. Okay. So again, I know this is a 45, 45, 90 because of the fact that they give me those 2 right angles. So this is leg, 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 square roots of 2. So the 2 legs we don't know are these 2. Those will be the same. So once I know one of them, I can find the other. But in order to figure out the leg, if I have the hypotenuse, I have to go backwards, just like we did up here. So leg times the square root of 2, so to find the leg, I'm going to divide by the square root of 2. So, and again, we didn't really talk about how to divide square roots, but hopefully if you have the calculator that divides nicely, or that simplifies square roots nicely, it makes sense. But really, square root of 6 over the square root of 2, we didn't really talk about this at all. It's really just the square root of 6 divided by 2. So that's just going to be the square root of 3. If that's the square root of 3, this also has to be the square root of 3 because of that 45, 45, 90. And if you go backwards, it'll kind of make sense that you can just multiply that through. All right, we'll go to number 17 then. So in number 17, we never really saw one like this in our homework. So you might have been like, I don't know what to do with a trapezoid. So totally understandable if that was the case. They give us that this is a 45-degree angle, 3, 4, and then they want to know T and U. So, we haven't learned anything about trapezoids. So totally understandable if you did this and you were like, I don't know what to do with it. But, so if you notice, a trapezoid is really just, and if you didn't know this is a trapezoid, hopefully you notice, they really look like there's a rectangle here with a triangle. So if I drew another leg, or another side in there, makes it pretty clear that this is a rectangle. If those are all right angles, this would be 4 and this would be 3. Because that's the way a rectangle works, the opposite sides are equal. So what I have here is I have a triangle. If this is 45 and this is right, this is also 45. So I have a 45, 45, 90 triangle. And I know this side is 4 because of that. If this is 4, this is also 4. The hypotenuse then would be 4 square roots of 2 because of our special right triangles. So that's my T value. So again, if this is 4, this is also 4. So this whole way across is 4 and 3 together, which would just be 7. So kind of, I guess, kind of different problem, but still using those same ideas. And then we go down to number 18. The 18 kind of similar, where not a shape that I showed you guys before. And this one's definitely a little bit tougher. So in this case, hopefully you notice that this top one is a 30, 60, 90. The 9 square roots of 3 is which side of that 30, 60, 90? The middle. So in order to go back to the short side, if you look back up at what I had on the top up here, so if we know the middle to go backwards, we're going to divide by the square root of 3. Since the short side times the square root of 3, so the short side is just going to be 9. Once I know the short side, then I can find the hypotenuse. I have to double it, so that'll be 18. So that gives me 18 here. And what this triangle is, the bottom one, is a 45, 45, 90. That's bad drawing. Not much better, but okay, we'll go with it. and they want G, and we know this is a 45, 45, 90. And again, if we know the hypotenuse, to find a leg, I have to divide by the square root of 2. So I'm going to have to take 18 and divide it by the square root of 2. Now some of your calculators do that for you. Otherwise, some of you guys have to do the steps. So it's going to be 9 square roots of 2 for this 2 sides for those values. Definitely a tougher one, but doable. Okay. All right, so we are going away from special right triangles for a bit. We're going to have 3 sections of new notes this week, and then we're going to start getting ready for a test. So we probably will test early next week. I'm thinking Tuesday next week. So 3 notes of new notes today, this week. So that means if you're still thinking about retaking our last chapter test, I would suggest trying to take care of that this week, so that next week you can just focus on getting ready for this test. So we'll probably still have another one after that before the end of the semester at least. So we're kind of going away from special right triangles. We're talking about trigonometry today. So if you don't have your calculator here, you're going to want one. So either you'll want to get one from me by turning in your cell phone or grabbing one from your locker. Because what we're doing today is nearly impossible without a calculator. Yes.
It doesn't blow up.
I don't know what I did to
Sad. Hitting it should help, yeah.
Yeah, normally it doesn't. Like, actually,
Maybe because you hit it all the way. Oh, sorry. You don't need to kind of simplify it. I don't know what it was, Jody, but I just cleared the memory. There's like a reset button on the back.
Yeah.
And once I did that, it worked. So it's healed.
okay, well, thank you.
You must have done something that anchored it and was counting. Seems to have anchored it.
It had too much memory.
Yeah, making it work too hard. Okay,
You're gonna make it
good on you.
I should be scared.
So, the warm-up question is asking you to do something kind of weird that probably doesn't seem very useful, but there's different settings on your calculator, and we want to make sure your calculator is in the correct setting. So if you type in sine, that's sine, not sin, and you can call it sin if you want. Sin 30, it should equal 0.5 or 1/2. Now, if your calculator doesn't do that, it's in the wrong setting, so we have to switch the setting. Especially if you like have an older sibling that's taking calculus or something, it's possible if you use their calculator after they're done, it's in the wrong setting. So sine, it should be in the, like, yeah, it looks like sin. You type in 30 behind it, it should say 0.5 or 1/2. Yeah. Because there's different settings on your calculator, and what you're doing in this case is we're doing the sine or the sin of a 30-degree angle. Now, depending on what kind of math you're doing, your calculator might be looking for something other than an angle or a degree for an angle. You can measure angles in other ways. And so if you don't get 0.5 or 1/2 for that, your calculator's trying to do something more complicated. Like my calculator tells me it's looking at degrees. There's like a little DEG written in the bottom of my screen, and that's how I know it's in the right mode. I can't remember if yours is on the, like, you guys have this calculator on the top. It says DEG. So that's the mode you want it to be in. Are you in the wrong?
No, I don't know where it is.
Oh, the sign. So it's, oh, yours find that sign button that's sin? Okay. And so this is the start of trigonometry. Now trigonometry sounds extremely difficult, like oh my gosh, and we're in like a whole different class. It's not bad. It's probably my favorite thing out of geometry to teach and to learn because I think it's really applicable. It's something that like my dad uses in his job and he works like kind of engineering. So he uses trigonometry all the time. It's something that can come up in certain careers. So when we're talking about this trigonometry, we're talking about these little buttons that are on your calculator that look like sin, cos, and tan.
Tan?
They should probably be close to each other. And Mitchell, yours are kind of like all in that, probably that same little heading. We're going to use just tangent today, which is tan. Now these are kind of like little nicknames, and then there's their full names. Sine, cosine, tangent. We're going to learn about tangent today, and then we're going to learn about sine and cosine tomorrow. Now the reason why this is in this chapter is because this trig information, it allows us to find out information about right triangles. So just like we've been doing all chapter, trigonometry allows us to find missing information about right triangles. So it finds missing sides, missing angles, of right triangles. So that's kind of the bare minimum of trigonometry that you like, if you know, like kind of the most basic part of trigonometry that we're going to do. So again, there's full classes on trigonometry that you can spend time doing, but we're going to focus on just kind of the simple trigonometry today. So we're going to work with tangent today. And tangent is a ratio, so that means it's a fraction. And the tangent, we're taking the tangent, this has to be an angle measure. So it's saying the tangent of angle A. That's the way we read that. So if you wanted to say that, you wanted to talk geometry, trigonometry at lunch, you'd be talking about the tangent of angle A. And that's an angle measure. And what the tangent of angle A equals is the ratio of side lengths. So now we're going to talk about side lengths in these spots. So we're going to write the opposite side over the adjacent. And again, these are sides. Opposite side over the adjacent side. So when I'm talking about angle A, I'm going to go over to angle A. I'll just circle angle A here. And I'm going to label everything based off of angle A. So one of the sides in this triangle is called the opposite side. Where do you think the opposite side is going to be located? Between B and C, it's going to be opposite angle A. So it's across the triangle from angle A. So the name kind of gives away where it is. It's opposite angle A. So there's our opposite side. The next side I'm going to label isn't listed here. That's called the hypotenuse. We know where that is. Where should the hypotenuse be? Across from the right angle. So and then the third side is kind of a weird name, but it's kind of listed here for us. It's given to us. It's adjacent. Do you know what adjacent means? We use adjacent when we're talking about COVID, that like if you're close to someone, you're next to someone. Adjacent means next to. So it's the side that's next to angle A that's not the hypotenuse. So this one, the leftover, is going to be the adjacent. Guys, make sure masks stay over your nose. I feel like a lot of you guys are not doing that. So this is just setting up what we're going to be working on today. So the tangent is this opposite over the adjacent. This first problem that we're going to do, this first example, is going to be like the first two problems in your homework. And it's going to seem really kind of useless, I'll tell you that right now. It's just kind of trying to get you guys comfortable with understanding this ratio. So in this case, the question says, find the tangent of n, tangent of L as a fraction and a decimal rounded to 4 decimal places. We won't go 4, we'll go like 2 or 3. So tangent of n, that's telling me I'm working with angle n. So I'm going to label everything based off of angle n. Ignore the other half of the problem right now. So we're going to figure out what tangent of n is. Now we make a fraction bar. And the tangent, again, should be the opposite over the adjacent. That's always the case. So that means I have to label this triangle based off the... Let's start with the opposite. Where's the opposite side to angle n? Which one? ML. So here's our opposite side. So the opposite's supposed to go on the top of the fraction. So rather than writing ML or LM, I'm going to just write 9 because I want it as a fraction. Now I like labeling the hypotenuse next. Where's the hypotenuse? Where's our hypotenuse? Yeah. Yeah, so there's 15 here. So there's our hypotenuse. The leftover is our adjacent, which is this 12. So that's what's going to go on the bottom of the fraction. So okay with where we got those numbers from? Okay. Can we simplify that? 9 over 12? Divide by 3, so we get 3/4. So that's the tangent of n as a fraction. Then they also say as a decimal, tangent of n would also be 3 divided by 4 is 0.75. So that's the 2 different ways we're going to write it. So the first 2 problems in your homework are going to ask you guys to do this. But now, what are they saying to do? Tangent of L, what does that mean for us? What does that do to this? You guys, honestly, gotta have to keep them up. That's the rule. I'm so sorry but this is the only class I have to do that in. Just keep it up, please. So, L, where is our L? What sides are, what happens there with L? What does that do to it? Is it the same answer? Because isn't that opposite over adjacent? No, what happens? Go ahead, Caitlin. What does it do to us? So here's L, now what happens?
So then, what was the adjacent is now the opposite?
Yeah, so this kind of crosses that out. Now that's just become the opposite. So we're like changing our perspective. Just like if I said, who's sitting close to the teacher and I walk out of the room, I mean, so that'd be then Miss Miller, or then or in the front of the room, you're like, well, which teacher are you talking about? Which angle are we talking about? So it depends on the angle, it's perspective. So we have our opposite there, and now where's our adjacent? 9. The hypotenuse won't change. So now this has just become our adjacent. So it changes that perspective. So it just depends on what angle they're telling us about. So again though, the tangent is always opposite over adjacent. So this is going to be 12 over 9. So it just flips that. And I can simplify that to be 4/3. And so as a decimal then, it's 4/3, it's 1.3 repeating. So to tell you the truth, these again aren't the most useful problems in the world. We really didn't figure anything out. All we did was set up a fraction, which is seems kind of silly. What we're going to do now with that is we're going to use that to find missing side lengths. So that's we're going to look at example 2. Now in example 2, I can't find the value of x without trigonometry. Because normally we can use Pythagorean theorem, a squared plus b squared equals c squared. But I only know one side. I can sometimes use special right triangles. That's a 45, 45, 90 or 30, 60, 90. This is a 10, 10, 80, 90. There's no triangle, special triangle with a 10. So we're going to instead use trigonometry. And today we're just going to work with tangent. Now, I always want to do the tangent of an angle. What angle do you think we should use? 10, because that's the angle they tell us something about. Now in my other class, someone asked, can you ever use 90? 90 is a little confusing because 90, the opposite side and the hypotenuse would actually be the same side. So you actually never do the tangent of 90. If you actually check it in your calculator will give you an error. So we're tangent of 10, and the tangent needs to equal the opposite over the adjacent. Where's my opposite side in this triangle? Opposite is x. There's my opposite. Again, my hypotenuse is across from my right angle. So what does that make 16? Adjacent. So we have tangent of 10. It's going to equal opposite over adjacent. So what over what here? X over 16. Opposite over adjacent. Now I want to figure out what x is. So think about your algebra skills that you guys have. If I want to solve for x, what's happening to x right now? What math is being done to x? Division. What's the opposite of division? Multiplication. So rather than dividing by 16, what can we do instead? Multiply by 16. Now, you've probably never really done this before, multiplying tangent of 10 times 16. I will warn you guys, if you change this up, if you do it this way, it's possible your calculator does it wrong. That has to do with the fact that it wants you to make sure that they know what you're taking the angle measure of. So I would suggest putting it in this way, 16 times the tangent of 10. And you're going to get kind of a crazy answer. It's going to be a lot of decimal places. But it should make sense for the triangle. So try putting that in your calculator. See what you get for your x. I'll put it up here, but check it on your own. See if you guys can get your calculator to do that as well. So make sure you guys know how to punch it in your calculator. Yeah, depending on, I think on the homework, I think they tell you just one decimal place, but yeah, that's fine. I put up 2, it doesn't. So you guys, you know how to enter it in yours, because yours is a little bit backwards compared to some of the other ones. So, it's actually, you have to put it in the order it's up there. So 16 times the tangent of 10. So if you don't get your calculator to do this, Make sure you're asking. We got it to work?
Place ask the calculator to speak.
Okay. So, before we make this tougher, I want to make sure we understand how to find x when it's set up this way. So, if that side of the room wants to go grab some whiteboards, please.
No.
So, over here, guys, grab whiteboards. If you guys want to. Whoa.
Jeez.
Okay, thank you. All right, good. Keep rolling. I know. Yeah. Yeah. Now you know my world. I mean, I like people losing pencils.
Like, I just made them a mechanical one, who's all I get to know the
Yeah,
Well, then break up with you.
Oh, I hear ya. I did just order a new pencil sharpener though, so it should be coming, I hope.
Soon.
Yeah.
Get refunded. That phone. Yeah.
Okay. So. Just third hour and grades. No one else said anything. I mean, I don't know. Yeah, that's good. Yeah, you can go like one decimal place is fine. Yes, yes. Sorry. It's okay if you guys are still trying to. Okay, that's okay. We'll talk about it. Thank you. Yes, that's good. All right. Do you want me to show you guys this one? Are we stuck? Okay. So the angle we know is 50, right? So it's going to be tangent of 50. We know that. That's the angle measure. It's across from which side? X. That's its opposite. Remember, the tangent is always, the tangent of the angle is opposite over adjacent. So this is my opposite. Oops, if I could write opposite rather than changing. Opposite. So it's going to be x over, and then here's my adjacent. X over 8. Once I have that, in order to solve for x, what am I going to do? Multiply by 8. And then show me what you guys get. Make sure your calculator gets the right answer. There you go. Thank you. Oh, no, I just wanted to make sure you knew. No, it's fine. I was just trying to make sure some people haven't gotten it. That is. Yeah, that's it. So, 8 times. So start at 8. No, you don't do that first. You do 8 times that. And then tangent. 9.5.
He's okay.
Okay, sorry.
No, we didn't know.
Okay, no, I know, I just.
Wait,
No, I was gonna have to quarantine him.
I know, I didn't like, I don't know, I just wanted to hear on this side of caution, sorry. Okay. Are we okay? Did you, oh, let's look at your. So guys, you should get like 9.53-ish, okay? One of the things is, yes, sine, cosine, tangent are all different operations. So if you if it says tangent, we have to use tangent. We'll talk about those other two tomorrow. So let's try a few more to make sure we. Yes. Yes. You got it. Good job. Yes, good job. Fine. Yeah. Yeah. Yes, yes.
Yes,
Yes.
good job.
Yeah. More. Yes. So now you have to solve that. So now you have to get the x alone. Yes. Well, you're gonna need yours. Are there not? Oh, don't use that one. That's the one that Mitchell just didn't want to use because it's bad. It says. So it's tangent of the angle. So tangent of 25. So you should write tangent 25. Yeah, that's gonna be the side leg. X over. Yeah.
Could make that PTSD. No.
This would be divided by 7, so it's multiplied by 7.
Maybe.
Uber tired.
Maybe when you get full.
I like 2. Yeah. You're not supposed to sign up on the last second. Right. Because Peyton has a game tonight, and I actually had somebody schedule Zerina's game, and I asked if I could just do this dinner. And they were like, oh, yeah, you know, like, I still wanted to block it off. I don't know. Okay, guys. So, when we do this, you guys, it's tangent of an angle. And the angle we're going to use, since the angle we know is 25, we're going to use 25. Across from the 25 is our opposite side, so that's our x. Over our adjacent, which is 7. I know this is new to you guys. I mean, none of you guys have done this before, so, or probably not anyway. And so this looks different and strange, and we're just trying to get used to it. So in order to get that x alone, it's being divided by 7. So instead, we're going to multiply each side by 7. So then these will cancel. So I have 7 times the tangent of 25, and I want to type it into my calculator this way, unless you have some sort of finicky calculator that you have to rearrange order. But you end up with like 2.3 something.
I thought it was 3.2. Yeah.
Oh, it's a 3 point?
Yes.
Oh, sorry. Oh, my calculators. Okay, yes.
I don't know why I memorized it.
So 3.26, there we go. So that is our answer for this value. Now, first of all, it should make some sort of sense. 3.26 looks about right in this drawing. If your answer is like 326, I'd hope you'd be like, what? I did something wrong. You know, like kind of realizing that. So just be careful there.
That's not the scale.
Right, well, yeah, I mean, I know my drawing's not always good, but like that's pretty
No,
far off.
3.6 to 326, that's not.
No, these are outer squares.
There's.
It was simple.
Solving for x. Yes. 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 Yep. Yep. Yes. Yes. Yep. It's, it's at 4. That's,
My Franklin cheese.
I think you need- you have a 20. This is a 70.
I was looking at.
Yeah, you're good. Yes. Yes. Good job.
Well, you showed me the right way.
Well,
We'll dump it off.
no, this one's harder. There's no good setup, right? Because of the writing on this.
I'm only at like 27 for now.
That's why I want to make sure we really get this down well before we make it harder.
I just didn't know what to do next.
Oh. So times 12 times 12. Okay. There you go. Okay, so here's our angle of 70. Our opposite side, our adjacent. So it's going to be opposite over adjacent, so I'm going to multiply each side by 12. And this time I get like 32.96 or something like that, right? Yep. Okay. Okay, guys, why don't you guys just set your boards aside, because I want to show you guys the next type of problem, and then we'll practice with the boards a little bit for that. Dun dun dun.
They're going to the bathroom.
Okay. So guys, so example 3 is a little bit tougher. So we're going to talk about what to do with this situation. So, what angle are we going to use? 38. So the question before, Leah had asked me, Leah was looking a little bit ahead here, and she's like, ooh, this has letters too for the angles. Don't worry about the letters. So angle B is 38. I'd probably use 38 because that's the one I know, right? So tangent of 38 equals
14.
opposite, and then our adjacent you said is y. Why is this one harder?
Because they split.
Yeah, the y is in the denominator. So there's 2 different ways we can go about this. It's
Oh
really,
my god, I did the wrong way.
so yeah, make sure y is in the denominator because it is the adjacent to 38. Any thoughts on what we could do here?
Flip it.
Just flip it.
Yeah. Reciprocal.
What's that? You think you know?
No.
Oh.
Understood what he said.
Oh. Alright, so I'll show you guys how to solve something when the y is in the denominator. So this is a little bit tougher problem when y shows up in the denominator. And I hear some of you guys saying reciprocal and flipping things, and that's kind of the idea we have to think about, is we have to get this y out of the denominator. If I do this, does that help you at all?
Yes.
Yeah, is that what you said? Like proportion? We're not going to flip it next. I guess you probably, well, then the one. I'm going to do proportions instead. So I'm going to cross multiply here. So I'm going to do y times the tangent of 38 equals 14 times what? Just 14. How do we get y alone now? Yeah, we want to get y alone. This is being multiplied by the tangent of 38. So instead we're going to divide by the tangent of 38. So y is going to equal 14. Now rather than multiplying by, we're going to divide by the tangent of 38. So again, take a minute to make sure you guys know how to put this into your calculator. Because again, these aren't things you guys can do in your head. We have to know how to put these into our calculator. 14 divided by the tangent of 38. Well, your calculator is probably a little bit tougher, maybe. Yeah, that's it. Good.
17.9.
Yeah. 17.9.
It's not even that hard, just divide.
Yeah, I just wanted to make sure you guys didn't, like, you don't want to freak out on this. So, let's go back to our whiteboards for a bit before we look at the next problem. Oh, goodness. We have a chicken?
Yeah. All of a sudden, we're in a farm.
Okay.
Oh, you want to be the dog? No.
Actually, I'm pretty good at barking.
Brody's like, no.
So disappointed in us.
Because you can fart.
Okay, guys, try this one.
Okay,
I don't want to.
10, 72.
Does it want to have?
Then 1 over x. Oh shoot, I'm gonna forget how to do this one.
Well, that's why we're practicing.
What?
Oh,
Hang on,
man.
We need to do the cross multiplying. Yep.
Wait,
72.
so.
Okay. I like to be in the front of it.
Is that in
They'll equal.
Run away from it.
So you're going to cross multiply.
So.
And then to get extra multiply.
Wait, am I really right on that?
No.
Is it the, oh, I didn't like it.
Good job.
Did I do something wrong here?
That's too big.
Never
Make
mind.
that go away.
Good job.
Wait, this one.
Sticker this?
What did I do?
Yes.
Wait.
Yes, good job. Yes, good job. So you have to divide this side by the 2. So you have to divide it here, you have to divide it over there. Very good.
Why?
Yeah, go ahead.
I just,
Yeah. Yeah.
20 divided by. So it's 6.4.
Yep. Yeah. Yeah. Like I said, this is like one of my favorite things. It's just like really logical to me. I don't know. Yes.
The
Right,
tangent.
by that.
Don't forget your tangent. You're missing tangent.
There
You have to do
go.
the tangent of the angle. Yeah. Yeah. Sorry. Yes. Yes. I kept thinking your 12. Your 2 was an 8. Yes. You're good. Yes.
Okay,
Yes.
so then it's 20 you're divided by
Yes.
Well,
12.4.
Because 58 is a fraction. So 20 is opposite. Okay. Okay. No, no. So this is the opposite that should be on top. You're good, yeah. And now, you're gonna put this in this one, you're gonna cross multiply. What's up? Slower guns can't.
I don't know what that is.
what? Wow.
Okay, you have that.
The cap is fun.
Okay, so it's x times the tangent of 58. So then to get x alone, I'm going to divide by the tangent of 58. So 20 divided by the tangent of 58 is about 12.5. Let's do one more, make sure we kind of got everyone on board with it.
I'm hilarious.
I'll be pretty mad. Also, I got scared.
You don't need it.
Don't need it.
Okay, guys.
Okay, I'm a genius at this song. It's okay.
Careful, it might have been kind of tricky here.
Oh,
You're right, you're right. No, yes.
I did something.
Wait, was it
Okay, it's a no, no. Okay, guys, look at what's opposite.
Oh, shoot.
Not every problem is the same kind. You have to be careful. Like your opposite over your adjacent. Even back the whole time. Yes.
No. Wait, how do you do this now?
Can go back to the Oh, good, right. We'll rewrite that now. Yeah.
Oh, wait,
Yeah. What's the first thing you learned?
I did it, I'm a genius.
Yeah.
Oh, I got it.
Oh my
Yes.
god.
Yes.
I can beat that.
So guys, careful on this one. Tangent is 74, but opposite is now the x again, over the adjacent. This is the kind that the first time we learned. So this time instead, we multiply each side by 8. So just be careful about the difference between those two. So it's 8 times the tangent of 74, so we get about 27.9-ish. Okay? You guys want to clean up boards, please? Yeah. Oh, yeah. At first I didn't know who the top hand was, but it's like I knew what the thing was supposed to be.
I just realized it was another video.
Yeah, we're recording, you guys.
Oh, that's right. I've been dying for the last 10 and a half minutes.
Why? I'm yelling at you.
Okay guys, so I want to remind you guys that we know how to solve special right triangles, but this also relates back to, like, this works with trigonometry or special right triangles. I'm going to call this one N, that's not labeled right now. So I'm going to call that little top side N. So this is a 30, 60, 90 triangle. So technically you shouldn't even have to do trig for this, you could use special right triangles. However, now that you know trig, I just want to show you guys that the two really do connect. So the angle we're going to work with is 30. What's the opposite side? N. What's the adjacent? 4 squared to 3. Not a great number, but you have a calculator. So how do I get the N alone?
You,
Yes.
5. Well, no, subtract. You do something.
So N is being divided by 4 squared to 3, so what do I do? Multiply by 4 squared to 3. Yeah. Okay, so in your calculator, 4 squared to 3 times the tangent of 30 should give us an answer that's going to make some sense. What'd you get? 4. Does that make sense with our special right triangles?
Hang on, I am having trouble.
Okay, you're having some technical difficulties.
Wait, what do I
Yeah.
do?
Right there. So you have to, no, you have to, so you have to 4 and then do second and then that little square root.
Who's done?
Yep.
Oh, when I try to multiply it. Oh.
Sorry, do it again. Okay, do you guys get to work? Okay, you should. It's above the little here. It's squared.
I got a better one.
You have to increase your own support. So it's 4 times the square root of 3. And then you have to close that parenthesis, sorry. And then you have tangent. Now guys, on some of your calculators, on some of your calculators, you might have to close this parentheses off or like arrow over to make sure you guys are out of the square root. So you might have to do a little bit of work to get out of there. But 4 squared to 3 times the tangent of 30 should be 4. Does that make sense with my special right triangles?
Yes.
Yeah, because this would be the short side. What would the hypotenuse be then? This is the short side, this is the middle.
No.
Okay, so this is just from last class.
I'm having issues.
It's 8, it's double. So this is 2 times the short. So 2 times 4. So this would be 8. What's another way we could have found that had we not wanted to use special right triangles?
Could have just,
If I know 2 sides of a right triangle, how can I find the third side?
But A squared.
A squared plus B squared equals C squared. So if you're ever stuck, you can always still go back to the things you guys know how to do. These all kind of connect with one another. All right, let's finish with this last problem.
Oh, what the heck?
So there's a flagpole. We want to know how tall the flagpole is. Maybe it's like the tallest flagpole in the country, like the one or the one in the world, the one that we have in Sheboygan up there.
Is that actually a tower?
Yeah, it's the world's largest, largest symbol of acuity. Yeah. Have you ever been like right underneath it? That pole is huge. Like,
Where is it? Like,
in Sheboygan, that really big flagpole by Acuity is.
Yeah, it just ripped and they just had to fix it.
Yeah, it ripped like during like it was crazy. It was like torn in half. They said the flag weighs like hundreds of pounds. Like it's so crazy. I ran over there once because my car was getting fixed, and so I went like underneath the pole, and like the pole, like I mean, we need a bunch of us to like put our arms around it. Like it's so big. Like you almost like tip backwards. Okay, this pole is not that big, but to measure some object that you're measuring. This is actually there's a measurement we can do with an angle, like there's like a little, I forget the name of it right now, but there's a way to see how high up you have to look at the top of the flagpole. So if I'm standing underneath the QD flagpole and I have to look really high up, the angle's really big. So I'd be able to measure that using like an engineering tool to measure that angle. So rather than having to climb this flagpole, I can use that tool to figure out how tall that would be. So this is our angle, which is 40. We're going to do the tangent of 40. The height of the flagpole is going to be our what? Our x, or our opposite side. This is the hypotenuse, so I don't want that one. So that means this one's my adjacent. So I want to get my x alone. So it's being divided by 15, so instead I'm going to multiply by 15. So 15 times the tangent of 40. You're going to do your calculator, you're going to figure out the height of the flagpole. And again, this is not a very tall one. 12.5.
I got 12.5.
This and then feet.
Okay. So it says to the nearest foot.
Foot.
What would be the nearest foot?
Foot.
13 feet. Oh, guys.
Why?
I love it. You blame her. 13 feet.
No, that's 3 centimeters.
Okay. Questions, guys? All right, homework is listed there. If you're struggling with this, please come in for help. Or if you're struggling with some of the past sections, let's do that rather than going to this test not feeling well. The test is going to be on Tuesday.
This week?
No, next week. 2 days tomorrow. Yeah.
You know, one time I definitely
Yeah. Yeah. Brody, I emailed you the test, but I don't know if you'd be in person, but if you'd rather do it in person, let me know. We can work on it together in person. But like, I want to do the retest in person, but like the corrections, if you want to do those online, I email them to you.
I'll go.
Oh, I did.
Okay.
If I have trouble with it,
Okay, yeah, well, that's a good idea. Yeah, I just didn't know yet, and like obviously we didn't know. Oh, sorry, stop in the video.